All right, let's go.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to you attendees. This is Mark Richardson speaking from Vibrant Technology in Scotts Valley, California. So it's morning time here, maybe not the same for some of you. Today we're going to spend about an hour together and I'm going to demonstrate some new features in MEscope as well as how we use these features in our new product line which we call MechaniCom. Now let me just give you a brief introduction to MechaniCom. It's for monitoring machines or structures, or for environmental monitoring where you may have microphones and accelerometers. But in general, it uses the acquisition and post-processing capabilities of MEscope together with a larger database, a Microsoft SQL database, and then a second software program called the console, the MechaniCom console, that allows you to observe the data that's being archived into the database from MEscope and also do some post-processing on the data. So the console is designed for a vibration analyst, an operator, to look at data that's being monitored in the field or from a database, however MEscope is attached to the acquisition process. Then MEscope will post-process that data and archive it into the database so that the console operator can observe vibration, acoustics, as well as any other engineering parameters that may be acquired. So what we're looking at here on my screen is MEscope, and you can see there's a whole bunch of windows open. There's 12 windows that you're looking at here in the work area. If I close this project, and let's just go back and start with a, well, let me just leave it open here and show you what is in this project. So those of you familiar with MEscope know that this first panel here on the left, or this pane in what we call the project panel, has a listing of all of the data files that are in this particular project, and we denote it by VTPRJ. So you can see here's the file path for this particular project. It's on my disk. All this data has been saved. I've got two different structure models in here. We're going to use one of them. Actually, you can see the window that's open here at the bottom, and here's a picture of a structure model. And I have a couple of data blocks in here, and we're going to use that data. We'll look at the data. One of them is called 5 measurement sets. So we'll talk a little bit about measurement sets and how the data has been acquired on this machine, the rotor kit that you see in the structure window. And then we're going to look at the spectra. You can see some spectra there. This is a Fourier spectrum with some peaks in it due to the operation of this machine. And then down here in the shape tables, we've got some first order ODS data. So we're looking at operating deflection shape data from this operating machine. And then we've got some mode shapes in here, and they're labeled modified modes. Those came out of SDM, and we'll go into a little bit of that background, where those mode shapes came from. But you'll see how they're being used as this program runs in MEscope. And what we do is take the data acquired from the machine and actually expand it using the mode shapes so that we can look at an animated picture that makes a little more intuitive sense to us based on the acquired data. So I'll go into that again. Then we're going to come down here. Here's an acquisition window, and it's called 5 sets. And in there, we're going to use measurement sets, and we're going to do it under program control. Brian Schwartz, who's the operating our WebEx for you today, our GoToMeeting, has just given me a message.
Have him send any questions.
Oh, okay, yes. Brian has reminded me he's kind of the manager of our meeting here today, and you have the ability with this broadcast to send text messages. So
send questions to support@bibtech.com.
Oh, okay. Brian is telling me send your emails to support@bibtech.com. So later on in the broadcast, Brian is going to read those emails, and he's on here live also, so he can talk to me, and he'll read the questions that you have. And so we're going to show you a lot of things here today, but we want to take some time for your questions after we've done the presentation. I should also add that my son Mark, who's the project manager, director, we call everybody a director at Vibrant, of the MechaniCom project, he's on live here, so he may be speaking to you during this broadcast. Also my son Sean, who is our special projects director, who has had a lot of involvement and contributes to the design of the MechaniCom software and the technology that we're putting in it. So when we get to operating the console software, my two sons may correct me and interrupt me and explain things to you a little bit better. Okay, down below in this project still are a number of programs, and you can see them all here. And we're going to go in and talk about hotkeys. Now, this is a new feature we just added to the programming capability in MEscope. And also what we've done is made the programming, this is called macro programming. It used to be an option. Now we've bundled it into all of the packages. So no matter which package you may own or purchase or sell, this macro programming capability is built in now. What it does is it allows you to write spreadsheets, open a spreadsheet, and add to it commands, any of the commands in MEscope. So if you're doing any repetitive operations, or as you'll see we're using it here, we're actually directing the MEscope programming to take a different path through some different programs by pressing a hotkey, either up here on the panel. Here you can see up here there I've got 5 hotkeys up here, and they're defined, and each of them has a label on it that says that it's a different RPM. We'll come back and look at those in a minute. Let me finish up down here. I've just changed to a different project, but let me just explain here. We've got a main program that will be running in MEscope. Then we have one that's called Arrange Windows. We have one that's called ODS Acquisition, and we also have one called TAC Acquisition, which is acquiring and processing a TAC signal. So let me go and show you. I'm going to save this project, and I have another one that I want to open here. So I'm going to close this project and open a different one because it's got some pictures of the project or the machine that we actually took this data from. So I'm going to close this project, and I want to open this other one here called Simulation with Hotkeys. So we're not going to take live data today. We're going to look at data that's been pre-recorded, and then we're going to play that data through the acquisition window as if it were being acquired. Live data were being acquired from the machine. Okay, I'm going to stop this. Now over here I have some added files, and I want to show you some of these. Let's look at this first one here. Here's a photo of the actual, this is called a VTech rotor kit. We purchased this from a company called VTech Technology. and they build these things. They're light and they're cheap and they're good demonstration. I shouldn't say cheap. Some of them are very expensive, but as a demo for looking at rotating machine problems, unbalance, soft foot, misalignment, these type of problems we can diagnose with this MechaniCom software. Now, let me just say we're not going to get into that today, but next month we'll show you how we can diagnose some of these problems, especially unbalance. So here's a picture of the machine. You can see down here there's a tachometer. This is a laser tack that's shining on this disc rotor, and the disc rotor has a reflecting piece of tape on it. And then there's 8 triaxial accelerometers on this that we mounted on here. You can see 3 of them here, and then there's one on each of the bearing blocks. They are recording vibration data in 3 directions. So we got 3 times 8 or 24 channels of data plus the tachometer signal. So we've got 25 channels of data coming into the front end of MEscope through an analyzer. Let me show you another way that we sell MEscope. This is something new with our MechaniCom product line. I'm just going to show you some pictures. We actually bundle MEscope running in a box, and let me just open up and show you some of these pictures here. This is what we call our MechaniCom box. This is something that we manufactured at Vibrant now, and we bundle the software for monitoring and using this as a portable acquisition system. Now this one is showing 48 channels. You can see each of these bundles here, and I can pull these multi-pin connectors off and then attach all my accelerometers. We sell this in a configuration that goes up to 48 channels. It has to be powered, and there's a computer and an analyzer and everything in the box to acquire and process the data and put it into a database. So here's another view of it. Now there's 3 ways I can talk to this box or get data out of it, because the data is being acquired in the box and in its database. This is a Cat5 or an Ethernet connection, so I can hook up to a company network and then get onto the internet this way, so the data could actually be put into a database in the cloud. Or there's a wireless, here's another view of it. This box doesn't get very warm. The computer is the only thing that warms up a little bit, but there's no cooling fans in it, and it runs very cool. It's a portable system that you can take out in the field. Here's a picture of a 4-channel analyzer and the computer. This is a solid-state computer, and here's some other wiring in here. Let me just go through some more of these pictures. They're all a little different, but I just wanted to give you a flavor of what's in there. This is a MUX version. Now we sell it in 2 different versions, simultaneous and multiplex. So MUX is a multiplex. Here you can see it's just a rat's nest of wires and a power strip, but that's all connected up to those 48 multi-pin connectors. Here's a little cleaner look at it. So that's one of the versions that we sell, and then we also again you can have up to 32 simultaneous channels in this box. Now again, we're not manufacturing anything. We buy these Pelican boxes and package all this in here so that it's a portable acquisition system. There are just some more pictures. That's enough pictures. There's a little different layout. Here's a wireless. We don't use this exact one now, but this is a wireless router, so that you can walk up to this box if it's out in the field, or you can connect to it wirelessly and look at your data in the console. Okay, well, let's go on here. I'm going to close this one, and let's go back and get that other project. So here's MEscope with no projects, and I'm going to go back and get this one. It's called VTech Simulation with Hotkeys and Measurement Sets. Okay, so it's coming up here and it says, do you want to start the program AAA main, which is the main programming in here, and if I say yes, it will start the program running in MEscope. Oh, it's asking me if I want to connect to the database. So this is another step in the process. You can see this file here. It's called a DCF file, database connection file. This is a protection that we give the MechaniCom owner to keep to control access to the MechaniCom database. So think of this database as a very large database with multiple machines that you're monitoring. You may have a consultant come in and look at a problem. You're looking at the ODS of the machine and it's jumping all over the place, and so you give a consultant permission to look at your database, have access to it, and you could control his access for a time period and so forth. So this is a protection that we give, and all Microsoft databases require a username and a password. So that's basically what we've done is put that into a file so that you can control access. Now MEscope, you may have a number of these boxes running in the field on a permanent basis, and so they all need access to the database also. I'm going to go ahead and connect, and it says now I'm connected to the MechaniCom database. So that's okay, and I should be able to just go ahead and run now. You can see up here, stop all programs. So I've got a stop sign up here if I want to stop it, but you can see that I'm actually running a program here, and it's going to acquire data from a data block. We'll come back and look at this in a minute. I just want to show you how all this is running here. And so just imagine this program in one of our yellow boxes, acquiring data in real time and archiving it into the MechaniCom database. Now, if I come over here to the console, let me see if I can find it here. Here's a console down here. Here is what the console software looks like when I open it up and start running it. It's showing me that I've got 6 different machines in my database. So it's called the machine gallery, and you can see that this machine and this one and this one, 5 out of the 6 are offline. And down here we've got something called Toronto Tower. This is an environmental monitoring application where we're just monitoring ground vibrations at a building site. So we can have different types of monitoring going on, and these are just examples in this particular database. But you can see over here the VTech machine is on, the machine is on, acquisition is running, and that's the simulated acquisition that I showed you in MEscope. So MEscope is actually archiving data for this machine into the database. So if I double click on this, you'll see that I've got a trend plot here, I've got an animated picture of the machine, and I've got some little icons on here. We're going to come back and look at this in more detail, but because I want to stop this and we'll go back to MEscope. But here is very similar to what you're used to seeing, an animated ODS using data from the 8 accelerometers and then expanding the ODS using mode shapes. And think of this as a curve fit. We're curve fitting mode shapes to the ODS data that's actually been acquired. And if I put the cursor over here on one of these, you can see this one here is red. This is a red light, green light system. So I've set up some warning levels in here, and we'll come back to this, how we set the warning levels. But you can see as data is being acquired here, these are turning, some of them are green and some of them are turning red because we're exceeding warning levels, vibration warning levels. Let me go back now. We'll just put this down and come back to MEscope. You can see it's still running here. It's running its macro program. You can see these programs just bouncing along here. I want to stop, and we'll stop the program here, and we'll go through some of the steps that it's taking. So I'm going to come up here and hit the stop button, and it's stopped its program. Now I'm going to go over here and right click on one of these programs, the main program, and let's just take a look at some of the commands in here. All right, well there's some things that may not be clear, but every line of this spreadsheet has an MEscope command in it. And all you need to give it when you write the program is the window name. So it's going to execute that command in one of the MEscope windows, and then the target window command. So you can see here the first command that it's going to execute is that it's going to connect to the database. So when I started the program, it said you're not connected, and that was when it opened up the dialog and asked me which DCF file I wanted to use to connect to the database. Now the arrange windows is another macro program. It's going to run that once and just lay out all the windows. You can see that when it's running here as a MechaniCom post-processing program, there's quite a few windows. Here's one called define a variable. So these programs, we have very simple parameters associated with them. And let me change the display here, and I'm going to split. I'm going to put this is another feature in MEscope where I've got two spreadsheets in here, and I'm going to put this is the command spreadsheet, and down here are the parameters. So I'm going to expand this one a little bit so you can see. And here is okay, so what I'm going to do is I've got 5 different examples of RPM data that I've collected on this rotating machine at 5 different speeds. And each of those speeds is going to be a different set of data, and we're going to use measurement sets in the acquisition window to acquire data for a particular speed. So that's what that's all about. Now this one here says hotkey RPM. Remember I had these 5 hotkeys up here? So here it allows me to, while the program is running, switch the simulation to a different hotkey. And we'll go back and run this in a minute, and I'll show you how that works, because these hotkeys also show up in the console so that I can direct MEscope to do different things using its macro programs while it's running in the yellow box or remotely anywhere on the network. Okay, here it's doing a little fancier. Here it's assigning. It's just saying variable 1 equals variable 2. In this case, variable 2 is a 1, and variable 1 is the hotkey RPM. So this is a little bit of programming that's part of the MEscope macro programming. Now this next one is saying set the hotkey RPM to the measurement set RPM. So we've set the hotkey RPM, and now we're going to set, okay, it's saying measurement set. I would think it would be the reverse of that. But now it's going to set the measurement set. And you can see this is in the acquisition window. So it's telling the acquisition window to use a different measurement set. Well, what does that mean? Let's go back and look at the acquisition window for a minute. Put this guy back. Well, we lost him. So I'm going to hit the arrange. This window here arranges all my windows in MEscope. I'm going to run that macro program, and so that rearranges everything. So that's kind of a useful program to have with your projects. Okay, now we've got, here's the acquisition window. You can see that it's sitting on measurement set number 1 of 5. Now when I hit the keys here, you can see it's walking through those different measurement sets and the DOS are indicating the measurement set number. This is standard MEscope processing of measurement sets. And if I press the start button here, you can see that here's the data that is bringing in from a data block. Well, where's that coming from? Let's take a look here. That's coming in from a data block over here that has some pre-recorded data in it. So the acquisition window is pulling this data in. You can see the cursor is indicating where it's coming from. It's computing the Fourier spectrum of that data. You can see the peaks in the data down here. So this is real data that was pre-recorded on the machine. And I've got 25 channels, 8 triaxial, and the tachometer is on channel 25. So if I draw down here and look at this data, there's my tach pulse coming in from, you can see it's kind of a square wave coming in from the front end. And we use that to, in MEscope, to process, and this is 25, there's the Fourier spectrum of the tach pulse. Now we're only looking out to 6,000 RPM. The other thing I can do here is take it all the way out to the maximum frequency in this data, which is, you can see we're recording, the sample rate is 30,000 RPM. That's 500 hertz. We're getting 2,000 samples. And then in the frequency domain, that's 1,000 spectrum samples. Our frequency resolution is 30 RPM. So between the samples down here in the spectrum, we've got a 30 RPM resolution. If I change this to 100 here, you can see the display limits. Now you can see the tach pulse. So there's the spectrum of the tach pulse coming in from the front end. In this case, we're simply reading it from a data block. So that's how this simulation is working. Again, we're not hooked up to real hardware, so we're using pre-recorded data. And this is something that many of our users take advantage of in MEscope. If they have an acquisition window, they can use it with either a hardware front end or pre-recorded data. Okay, let me go back. I'm going to stop this and let's put things back where they were. Okay, they're all out of sync, so I'm going to run this little arrange program again that puts everything back. Let me show you these hotkeys, because this is a new feature we've just added to MEscope, and it's part of our programming capability now. So up here you can see that I've got a bunch of the menus available. This is a full, all the features available in MEscope. I've got SDM, FEA. I've got 2 other menus here. When MechaniCom is ordered, and that's an option, then I have a database connection. I've got a machine set up, and then some other commands in here. But let's go back to this one and look at the hotkeys. So here under hotkeys, I've got something called hotkeys set up. And here it is. So I have defined in another spreadsheet 5 hotkeys. And when a hotkey is pressed, it will execute these programs, these various programs. And then I can associate it with a machine name in the database, or I can associate it with all the machines. So again, I can have hotkeys that are only available with certain machines or with all the machines in the MechaniCom database to do different things. So just imagine that maybe I'm doing impact testing. I'm using the system to do some impact testing, some qualification testing. I can do some curve fitting in MEscope, save those mode shapes into the database, compare the values that I get, the frequencies, the damping, the mode shape, with some warning levels, or basically warning levels, think of them as some bounds, both plus and minus bounds on the data. And then, you know, I'll get a red light if some of these parameters are outside of their expected bounds. So that's another application or example of using hotkeys. Here we're using it just to fuel the simulation. Now let me go and open up one of these programs because they're not actually visible here. None of them are visible. So I'm going to go get one. Here's the hotkey 1320. So let's just open that up and see what that looks like. Okay, well that's just a single line program. And what it's doing is changing the measurement set number. And we saw in the main program that the acquisition window has 5 different measurement sets in it. And so if I press a hotkey, what I'm doing is telling the program to use, in this case, use measurement set number 1. Very simple application. And you can see here that in the window, it's actually passing. The target window is my main program, and it's saying here this command is let me make this larger so everybody can see it. The way I do that is hold down the control and spin the mouse a little bit. So this particular command says program variable. This is the command up here under the program manual under variable, and here it is down here. It's variable 1 equals variable 2 from program. Oh no, that one is different. That's gee, I don't see it here right. Oh, here it is right here. Variable 1 in program equals variable 2. So what we're doing is passing over in the main menu or the main program, AAA, we have something called use measurement sets. We saw that, and it's setting it equal to 1. That's what that is. So a little bit of computer logic there. Anyway, that's enough said on that. Let me show you then, and we saw the hotkeys here. Let's show one other thing, and then I'm going to turn this back on, and we're going to go over to console and look at how MEscope supports the database and the console. Here's a machine setup in MechaniCom. This is where I define the machine in the database. So I give it you can see it's already in the database. It's got a name, VTech Rotor. It's got a 3D model, a structure model. This is standard MEscope stuff. And here it is down here, expanded shapes. There's the model that we were looking at in animation. It's got what's called a monitored shape table. Now this is just a standard MEscope shape table. Where's that? Well, that's right here, monitored. Oh no, this one says, I think it's down here on the bottom. My monitored shape table is called first order ODS. So here it is. Here's the first order ODS data that's being put into this shape table. And you can see there's 24 degrees of freedom. The units are inches per second. So there's a step somewhere in MEscope where we took this accelerometer data and we integrated it so that we're actually putting units of inches per second velocity into the database. And these are the ones that are going to be monitored, these shape components here, to give us the red light, green light indication of whether these 24 degrees of freedom, these 24 accelerometer signals are actually within our prescribed bounds. You can see the first one going in here is a tax signal. Now that's a little strange. I wouldn't have expected that. That should be the, oh, I know what it is. We stopped in the middle of the program. The program, when the TAC program runs here, it actually puts the frequency of the data into the frequency of the shape table, and then it loads in, as the program runs, it loads the monitored data, the first order ODS. Here's the expanded, and we have another shape table called the expanded shape table, and again I explained a little bit of that. And then we're putting the frequency spectra. So that's another, we can have frequency, time, octave. And so all this defines to the database what data MEscope is going to archive in there. Here's the frequency spectra. Let's take a look at them. So here it is, and you can see a cursor set up there. There's a bad measurement. Turned out when we took this data that wire was actually disconnected, so that's just noise. But you can see, and here's the motor showing up out here at a higher speed, and the rotor, the main rotor, is hardly moving. We'll go back and take a look at that. There's the tack signal down there at the bottom. So there's the spectra that are going to be also pushed into the database. So I'm going to start this program running in MEscope, and this will just run forever. Think of it being in the portable acquisition box, and it's just taking data and pushing it to the database. So there it is. You can see it's picking up different data, and now this data is at what frequency? 2100 RPM. So is that right? Okay, so it's sitting at 2100. If I wanted to go to a different frequency, I push one of these hotkeys, and that will change it to a different measurement set. So here I'm pushing number 1, the 1320, and it'll take it a minute here, but now it's going to acquire the data. Again, a simulated case. You can see the frequency change down here, and now it's got an expanded shape. Now it's going to push that data into the database, and we can go over and look at it. I've been doing a lot of talking here. I'm going to turn this over to Sean. Would you like to speak first, or Mark, either one?
Doesn't matter to me.
Okay, well, let's go back to the machine gallery. Sean, why don't you give them an overview of what we're looking at here. This is the console that's reading data out of the database.
Yeah, so he kind of gave you the overview of how everything is set up and working behind the scenes. Most of that, you don't need to know. When you purchase a MechaniCom system, we set all of that up for you. All the macro programs, everything is built for you. Tell us, the type of data you want to get, how you want to get it, the frequency span, all those type of things, and we build you all the programming. And really what you do is you put the box down and you work from this end of it, which is the console end. You kind of talked about, the amount of, in this particular setup, he only has one machine going there. You can have several MechaniCom boxes at a, individual installation or at different places around the world, assuming you have internet connectivity. But when you do have that, you can have all your machines all in a single place in the machine gallery. And if you had, in this case, it would be 4 or 3 different boxes set up. All of these would say online. You get the compressor and the diesel generator and the hammer mill and the vertical pump. They'd be online, and then your environmental monitoring in Toronto would be online as well. And so this would just be your initial look at the status of your machines. Why don't we go ahead into get in the rotor?
Let me put that down.
Yeah. As you can see, there's the ODS animation. It's a little bit jerky because we're running the webinar here, so it kills the animation a little bit. But if you had this just running on your computer, it would be smooth, just like it is in MEscope. We can start with the model. Up on the ribbon, you can see it essentially has the same features that you're used to in MEscope. You can double click in there and you can get to quad view. You can do all the zooming. You can turn points on and off. You can turn on and off the deformation, go to color contours, change the amplitude, change the speed, all those type of things that you would normally do in MEscope. If you were doing operational modal or you were tracking multiple orders in ODS, there's a drop-down menu there at the top, and you could change the order that you wanted to view the animation for. If, like I said, if you were tracking the first 6 or 8 modes of a machine or a structure, and you were doing operational modal, you can go there and change the mode shape and look at the mode shapes. We can also put this in compare mode, which will put your current data that's been acquired side by side with the baseline data, which is our initial setup. So if you're balanced and you're all aligned and everything like that in a machine like this, it's going to be your current versus baseline. Your baseline will be on the right, your current's on the left, and you can use the slider bar. You can overlay the two to look at differences in the shape, or you can keep them apart like this. Same thing, if you're taking modes of a structure, a building or a bridge or something like that, it's valuable to look at how things have changed over time, how the shape has changed over time. Obviously, you're going to see that data change in your trend plot and your frequency spectra, but it's nice to be able to look at actual changes in your ODS or your mode shapes, and that's something that we're going to talk about in next month's webinar, is how to identify certain faults through shape changes and stuff like that. But again, your structure window is very similar to the way it works in MEscope, all the same features. Let's get some warning levels set up on our gauges, and I can show you how that works. If you click in the machine tree, we can look at the warning levels here. We added some warning levels when this was being set up. If you can scroll all the way down to the bottom. So we put VTEC-SIM. What we have it on is absolute units, so it's basically the data values north and south of 0. We're only going absolute units up from 0. So what we have our low alert level set on is 0.6 of an inch per second, medium is at 0.8 of an inch per second, and the high is at 1 inch per second. You'll go over that in all of these in the simulation. The rotor kit is sitting on a very flimsy table, so it bounces all over the place, so it comes up with extremely high values. Normally in an installation situation, you're not going to see that except in a very small machine, but for this, we'll show you how this works. So go ahead and hit cancel out of there. You can add as many warning levels as you want in this. If you go over to the machine tree and expand the VTEC rotor. If you have multiple shapes or multiple orders, what you can do is you can just go in here and you can assign separate warning levels to different orders. So if you're looking for bearing issues at 4 and 5 and 6 times running speed, you can set up multiple orders there, and you can have much tighter limits, so you can actually set off alarms just on those higher orders, and maybe not even see an overall RMS magnitude change. But to assign the warning levels here, what we would do is we just do a shift select. So if you click on 1X and then hold down shift and go out and all the way down and click on 8Z, and then we just right click on any of those. We go to gauge settings, and then there's just a drop down here that has all your setups. You just click on VTEC-SIM and hit save. You can see in the gauges in the gauge panel here, everything has changed now. It's a different look now. You can see green is all the way from 0 up into our first defined warning level, which was at 0.6, and the pins are your baseline versus current, so you can tell where your current data is versus where your baseline data is, and you have the color code for the alarm levels. Now if we go to the gauges tab up on the main ribbon, there's different functionality. You can change these ribbons. Let's say the one that's labeled frequencies, typically your tachometer gauge. Let's say you can click there, and maybe we just want to use a standard LED look to it. All these are different options here. You can change them. There's more that are thermometer type gauges, so if you're taking temperature or pressure or something like that, maybe you want a different gauge. But there's different options. You can make them bigger and smaller if you want. You can right click on any of these gauges and change the name of the sensor. Maybe you don't like 1X, 1Y, 1Z. Maybe 1X is on the inboard bearing, so you say inboard bearing vertical, horizontal, axial. You can name it whatever you want. It's flexible in that way, so you can change it. But that's the gauges. It shows you where your data is with respect to the alarm. But you can shift select in there, and you can make like he's doing here. You can change the size. You can make them bigger, smaller, whichever you want to do. Why don't we go over to the trend plot? Standard trend plots, you can overlay as many of the data points as you want. What we would do is we'd expand where it says shape 1 here, and you just select all the data points that you want on there that you want to display, and it's going to overlay all that data. You can change the color if you'd like to, but it's going to, it's going to give you that. That's probably enough. Just go ahead and close that. If we click on the chart tab up on the main ribbon, what we can do here is we can overlay our warning levels, which is on the far right of the ribbon. You can change the look, the appearance of the data, how it comes in. You can put it on bars, points, however you want. This will just be the individual point measurements as it goes with respect to time and frequency in that way. So there's flexibility in there as well. If you click on the warning level overlays all the way to the far right of the ribbon. Yeah, so if you check the display levels box, the box next to display levels, just next to, there you go. You got to check the box. There you go.
Ah, there we go.
So it's going to overlay the warning levels with respect to your trend data. You're going to see the data points that exceeded. You know, most of the time in a standard operating condition, if you don't have any faults or anything like that, all the data is going to be, you know, below your yellow line. It's going to be all good. You can control the thickness of the warning levels there. That was the slider bar that you saw under the warning levels. You can control the thickness of those warning level overlays. Everything from here, as far as reporting and stuff goes, you can export anything you see on the screen. And what it's going to do is going to export the data you have selected in the range that you have displayed. But you can export that to PDF. You can export it to a PNG file for an image, or you can export it to a CSV file, which is a Microsoft Excel file. So you can manipulate the data and display it differently in reporting functionality through Microsoft Excel. Other things that you can do from here, you can click in past areas within the screen, and you can animate that past data, or you can, you know, add manual events, different things like that that you can do. When we go to the Home tab.
Yeah, so this is shape data. What we're looking at here is the monitored shape data. So when I say animate, it's going to take that data and animate it. Well, actually, the expanded shape data, for whatever case I want to look at, it's going to put it on the animated picture. So I can actually go back and look at the ODS for any of this data that's being archived in the database.
Yeah, and that would be stuff that, you know, had archived in the past. Now if we go over to the Home tab again. Yeah, go ahead and click on Traces. There we go. This is the wrong shape, so you're only getting out to 6,000. But what we would have here, you can see the running speed in this situation is, I don't know, 1320 or something like that. And the way the baseline, you can hover over that peak and you can see where it is. We can overlay all our traces here the same way. Same selection functionality is in the trend plots. You saw in the acquisition window in MEscope, some of them he changed so it, you know, went all the way out to 30,000 RPM. This particular one for this running speed wasn't changed, so it's only to 6,000 RPM. But it's something we can do in here. We can right-click, and you can go to X-axis, which gives you your options for the X-axis. And it gives you the ability to overlay the operating frequency and the multiples of that. So that's basically the running speed. So if he clicked in there and he typed in 1320 and then click outside of it, yeah. So it's going to drop the running speed lines at all the multiples. Now if this went out to 30,000 RPM, you're going to see at every multiple of 1320, you're going to see where it hits, which gives you a good opportunity to, why don't you go ahead and right-click and do the plot selection and select a couple more measurements to add on there so we get the color changes.
Yeah, and then maybe we ought to switch to a higher frequency too, and or the higher RPM. We can show them the hotkeys doing that.
Sure, we can do that. But the same thing is in the trend plot. You can select what you want. You change the colors. You know, get an overlay here. But it's nice when you have the indicator for multiples of running speed, because it's going to show you where your primary peaks are. But when you expand all the way out, you're at higher frequencies, higher RPM. What it'll do is it'll allow you to see sidebands pop up, things like that are normal indicators of you know, bearing problems and things like that. So you know, that functionality's in there. Zoom control, you can zoom in and look. Same type of things in here. What you can do is you can export this data. Same way for, you know, reporting functionality, images, PDFs, that type of thing. So you can continue to manipulate the data and have reporting functionality the way you want. And the same thing, although the way it exports is based on what's selected. So just you know, good tool for reporting when you're taking data over a longer period of time. You want to go ahead and do the hotkeys and change the
Yeah, now
running
this is
speed.
going to be simulation of actually speeding the machine up. So I'm going to go here to Hotkeys, and you can see that I've got some hotkeys here. They're the same ones that are in MEscope. So when I define them in MEscope, they actually get assigned to this machine or all the machines, depending on how I define it. And now console knows about the hotkeys also, so they can be pressed right here from the console. So I'm going to press the 2300. What that's going to do is change to a measurement set number 5 and start acquiring data out of the data block for the 2300 RPM. So again, this is just a simulation. You wouldn't normally use hotkeys to do something like this, although you might. It just depends on how you want to define those hotkeys. Now, I don't see the new data coming in yet. Okay, there it is. You can see that my model is indicating 2300. My frequency over here is 2300. And you can see we still got the spectrum up here, and now the running speed is way up here at 2300 RPM, the main peak. Now, in order to put the orders back on there, I'd have to go back to...
No, they're on there. They're on there. They're on there.
Yeah, they're on there at
at
1320.
What,
if I put,
but this is a good indication. If you have a change, you understand where the operating speed of the machine is supposed to be. For some reason, I mean, you're going to have a lot more problems if a machine changes speed this dramatically. But if you do have a subtle change, it gives you an indicator where it should be running versus where it is currently running. And again, I'm not sure, which speed he set up over there in MEscope as to, which one goes all the way out to 30,000 RPM, so you can get a better idea of the peak indicators. But it's one of those.
Here's the ODS using that data, the expanded ODS. You can see that it's quite different. You can see a lot of the Excels or a lot of the traces of data is in our monitored ODS here are in the red, and you can go out here and you can see this whole loose end here. Now, we didn't tell you that we actually added a little unbalanced weight to this outside rotor. So at the higher speed, the unbalance is throwing this loose end here all around, and you can see those are all in the red now. And even this other one here is orange, so it's saying that the Y direction of that Excel is exceeding its levels. Over here, if I put it on here, all of them are, well, no, one of them is and two of them are orange. So I can get that indication either from here or from the animated picture.
We only have a couple minutes left, so just let me go through just a few more features. This is fully set up for text message and email alerts, so anytime you do exceed any sort of warning level, we don't need to show it. We just don't have enough time.
You can go to the settings, machine settings.
But we just don't have enough time, so I just want to cover the extra things. Like SMS text messaging and email notification, the box just needs to be connected to internet, so that's Ethernet connection to a network. You can use a cellular router and connect to the internet that way. All kinds of different functionality, but you'll be notified when something goes wrong like that. We also offer a camera option that you can plug in. Power over Ethernet is plugged in with the Ethernet cable. Gives you audio and video real time, so if you're trying to observe something visually like that, or you're trying to identify changes in pitch or tone, something related to the machine, it's good for that as well. Something that we'll cover next month is called FACS, which is fault correlation tools, and what that allows you to do is identify almost immediately essentially like events or different types of faults. Now, once a fault has occurred one time previously on a machine, what it does is it stores all the information associated with that shape, and it'll, as soon as your machine starts trending to another unbalance or misalignment or something like that, it's going to give you an indicator. Now, he kind of pulled this up. It has a bar chart indicator, so it's going to have how strongly it correlates to a previous shape. similar to the way Mac value works, your modal assurance criterion, except it also takes into account the magnitude of the measurement. So, but all the shape components go into that. You can select which shape components you want to have included in the evaluation, but it allows you to identify faults. So it's kind of a artificial intelligence. Essentially what your system does is it learns the behaviors of your machine, and you can save any type of behavior that has occurred before, and it'll automatically attempt to correlate it to your current shape. So that'll give you an indication as to the, what type of fault your machine is starting to indicate based on the strength of the correlation here. Like I said, we'll get into that next month. A lot was covered today. I know that we don't have a lot of time for questions, but Brian, did you get any questions?
No.
No? Okay.
No questions. Well, that pretty much concludes our presentation then. I want to thank you all for spending the last hour with us, and I hope that the bandwidth of your internet connection was good enough so that you could see what I'm showing on my screen. And as Sean said, the animation doesn't come across the internet as well as it does on the computer screen, but we certainly showed you a lot of features here today of both MEscope and MechaniCom. And next week or next month, if you come back, we'll announce it with a newsletter, hopefully a week or so before the next internet meeting. And we invite you to come back next month, and we'll go into more details of Brian has now got my okay, so no questions here. He's in here looking at my screen, but anyway, thanks for coming, and we'll invite you to come back next month for more discussion on MechaniCom, and hopefully we'll get some simpler programs together so that it's not so confusing to you how the programming is set up in MEscope. And really it's as simple as just acquiring some spectrum data and maybe some shape data and pushing that into the database, standard MEscope shapes and data blocks with traces in them. Okay. I'll say goodbye and talk to you later.